Hello everybody, welcome back to Mathematics for Engineering 3. It's me again, M. And this is the last section on the systems of differential equations. And we're going to be looking at the first order non-homogeneous systems. So basically, we're going to be looking at the systems of differential equations when the vector b, if you remember, the vector b is not a zero vector. Okay, in other words, when the systems are not homogeneous. Okay, so let's start here. The first order non-homogeneous systems. In the previous sections, we have been looking at the case when we have ax equals, x prime equals ax, right? When this vector b is a zero vector, but right now we allow b to be non-zero. Okay, and the systems are called non-homogeneous. Okay, this is the word non-homogeneous here. So if you remember in chapter 2, we look at the homogeneous equations, right? And then non-homogeneous equations. And the techniques used in this section is going to be pretty much similar to what we did in chapter 2. Okay, so here we would need to come up with the solution. So I will say the solution x is actually xc plus xp. Remember that in chapter 2 we did the same thing. We get xc and xp, and that's called the variational parameters. Okay, we'll be talking about that again. Okay, when xc is the solution, of homogeneous systems. Okay, xc is the solution when b is 0. Okay, when the systems are homogeneous. Okay, and xp, you can find the xp using the variational parameters. Okay, so to solve the non-homogeneous systems, first you need to find xc by assume that the systems are homogeneous. So we let b equal 0. Okay, then we find xc. After that, xp is defined in this way, which is a1 x1 plus a2 x2 plus an xn. When these x1 x2 until xn, they are the solution of homogeneous systems. Okay, it's actually from here. Okay, it's this x. Good. So first we assume that it's homogeneous, meaning that b is 0. Then we solve for x1 x2 x3 x4 until xn, and using the previous sections that we learned, right? Distinct roots, complex roots, and repeated roots, right? And then we obtain xp in this form. And if we look at the derivative of xp, we would have that it is a1 x1 prime plus x1 a1 prime, right? For this one, you need to look at it as u and v. So you get u dv plus v du. Okay, so it would be a1 x1 prime plus x1 a1 prime. And the next one would be a2 x2 prime plus x2 a2 prime, and blah 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 until an xn prime plus xn an prime. Okay, and I'll just rearrange the terms. Okay, so I can write it this way, which is a1 x1 prime plus a2 x2 prime. Okay, I move this guy, and this guy together. Okay, and then it will plus blah 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 until an xn prime. Okay, after that I plus a1 prime x1 plus a2 prime x2 plus blah 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 until an prime xn. Okay, and this is this term. Okay, and here is this term. So it's nothing, it's just, rearranging the terms. Okay, and then we substitute this and this in equation A, which is this equation. Okay, we substitute xp and x prime p into A. So what we have would be, what is it? X prime, right? X prime, that would be a1 x1 prime plus a2 x2 prime plus blah 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 plus an xn prime. Okay, that would be x prime, right? X prime, and then plus a1 prime x1 plus a2 prime x2 plus blah 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 plus an prime xn. Okay, so this term is actually x prime. Okay, we have x prime, so I copy this and put it there. Okay, and then we have a equals a, and then we need to have x, right? Ax, and what would x be? X would be just a1 x1 plus a2 x2 plus blah 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 plus an xn, right? This is xp here, we put it here. Okay, and then we plus b. Okay, and then we plus b. And guys, because x1 x2 x3 until xn, they are solutions when the systems are homogeneous, right? What does that mean? It means that x1 prime is actually a x1, right? X2 prime is actually a x2 and blah blah blah. Okay, so if you look here at this guy, x1 prime is actually the same as a x1. Okay, so this guy disappeared, they got cancelled out. Okay, guys, x1 prime is the same as ax1. I can put little a1 here as well, right? Little a1, little a2, it doesn't really matter. So a1 x1 prime, which is this guy, is the same as a1 big A x1, which is a1 big A x1. So they got cancelled out. See? And similarly, xa2 x2 prime would be the same as a2 big A x2, and this is a2 big A x2. So this got cancelled out as well, and you can see that all got cancelled out. Okay, so we have that a1 prime x1 plus a2 prime x2 plus blah 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 plus an prime xn equals b. Okay, and this is the most important equation. Okay, this is the most important equation. Okay, I'll put lots of star here. So you need to use this equation to solve for a1 a2 blah 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 until an. Okay, I wrote it here. A1, A2 till AN can be obtained by solving this equation. Okay. How? We'll see. We use Kramer's rule. Okay, it's pretty much the same as the variation of parameters that we did in chapter 2. Okay, so let me sum it up here. To solve the non-homogeneous systems, first, we assume that it's homogeneous. Okay, we first assume that it's homogeneous. Let me write it down here. First, we assume homo. Okay, and then we get x1, x2 till xn using the previous sections. Second, we let xp be a1 x1 plus a2 x2 plus blah 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 till an xn. Okay, after that, third, we solve this equation for a1, a2, a3 until an. Fourth, we get xp, and then the solution would be xc plus xp, which is here. Okay, so these are the the 4 steps we need in order to solve for the solution. Okay, so let's look at the examples. Well, this example, we want to solve the following equation. Okay, and first I'll write that down in terms of matrix. Okay, so I get x prime equals x prime this is actually the matrix of x prime y prime. Okay, so it's the big X prime. Sometimes you write like this to make sure that it's the big X. Okay, and that would be A, which is 0, 1, minus 2 and 3. Okay, and the big X, and then we plus t e to the t, and then e to the 2t. Okay, here you can just use x, like we used to do. You don't need to write it that way. Just make sure it's big enough. Okay, make sure that it's not the little x. Good. Okay, and right now this problem can be written in this matrix form. Okay, and this matrix is called the matrix B, and right now you can see that it's not 0. Okay, because before this is 0, right? Okay, and the first step is to solve for xc, right? To solve for xc, then we need to look at this system, which is 0, 1, minus 2, 3, x, when the b is 0, which is the homogeneous, right? This is the homo case. Okay, and to do that, we did pretty much the same as what we did before, right? We first look at this characteristic equation, which is minus m, 1, minus 2 and 3 minus m equals 0. Okay, we minus m to the diagonal line. You remember, right? The characteristic equation is determinant of a minus mi equals 0. Okay, after that we compute the determinant, and that would be minus m times 3 minus m plus 2 equals 0. Multiply up is negative. Okay, so you get minus 2, and that is plus 2. Okay, so we get minus 3m, and then plus m squared plus 2 equals 0, and that is m squared minus 3m plus 2 equals 0, and then we factorize it. We get m, 2, 1, and minus and minus. That means that m is 1 and 2. Okay, and you can see that this is the case when we have these distinct roots. right? That is the first case when we have distinct roots. After that, we would need to, get 1m. Let's say m1 equals 1, right? And then we look at this equation. Remember this a minus m1I k1 equals 0. Remember that? So we have, what is it? A, that would be minus 1, 1, minus 2, minus 2 and 2. Basically, we take this matrix A and then we minus 1 to the diagonal line. Okay, but it's a lot easier to look at this matrix and substitute m with 1. Okay, that's why we get minus 1, 1, and minus 2, 2. Okay, and there we get k1, k2, and that is 0, 0. Which means that minus k1 plus k2 is 0, minus 2k1 plus 2k2 is 0. But the two equations are the same, right? If you divide the second equation by 2, you would get the first equation. Then you have that k2 is actually k1. Remember, write k2 in terms of k1. So we have that k1 is k1, k1, and then we choose k1 as 1, so we get 1, 1, which means that x1, it should be xc1, right? xc1 would be, what is it? What is xc1? xc1, I'll just oops, sorry, I'll just call it x1, okay? I don't want to put c there, but right now we are getting xc, okay? So x1 is, what is it? 1, 1 e to the t, okay? And then we take m2, which is 2, okay? We look at the second m. So using the same equation, so we have minus 2, 1, minus 2, and 1. k1, k2 equals 0, 0, which means that minus 2 k1 plus k2 is 0. Okay, and we have the same equation twice, right? In that case, we have that k2 is actually 2k1. So we have that the big k2 is actually k1 and 2k1, and then we pick k1 as 1, so we get 1 and 2. In that case, we have that x2 is 1, 2 e to the 2t. Okay, and that is x2. Okay, right now we get x1, x2. So we know that our xc is actually c1x1 plus c2x2. Okay, that is our xc. So our xc would be c1, x1 would be 1, 1 e to the t plus c2, 1, 2 e to the 2t. Okay, let me get rid of my video. And this one, we can write it as c1 e to the t plus c2 e to the 2t e to the e to the 2t 2e to the 2t. Okay, and then right now we will call this x1 and this x2. It's actually the same, right, guys? Here, if you want, you can write this down as e to the t as well, and here is e to the 2t 2e to the 2t, right? So now we want to find xp. Okay, we want to find xp, and we let xp be, what is it? a1 x1 plus a2 x2, if you remember. Okay, from here, right here, a1 x1 a2 x2 until an xn, but right now we have only two dependent variables. So we can find a1 a2 by using this equation. which is a1 prime, what is it? What is the equation? a1 prime x1 plus a2 prime x2 equals b. And that is our equation, so that we can solve for a1 and a2. Okay, so let's say a1 prime. What is x1? x1 is e to the t, e to the t, plus a2 prime. What is x2? Is e to the 2t, 2e to the 2t, right? Equals b. Our vector b is t, e to the t, and e to the 2t. So we have t, e to the t, e to the 2t. Okay, so we obtain the systems of linear equation, right? It's actually this one. You can actually write it as e to the t, e to the 2t, e to the t, 2e to the 2t, and then a1 prime, a2 prime equals t e to the t, e to the 2t, right? It's the same thing. This one is this one, and this one is actually this one, right? You can write like that. Good. And then if you want to find a1 prime, it's actually, what is it? You need to put this one, this column, replace this column by this column, right? That is a Cramer's rule, if you remember. So we need to find this matrix, which is t, e to the t, e to the 2t, and then e to the 2t, 2e to the 2t, divided by this matrix, which is e to the t, e to the t, e to the 2t, 2e to the 2t. Okay, so if for those who forget the Cramer's, you actually first, if you want to find the first guy here, a1 prime, you replace the first column with this. Okay, and this is this guy. Okay, you replace, you put this to the first column, and then here remain the same. Okay, if you look here remain the same. I'll use this yellow color here. Okay, you replace this column to this column, and then this guy is the same as this. Okay, so you need to find that determinant. Okay, and here it's quite simple. You get 2t e to the 3t minus e to the 4t divided by 2e to the e to the 3t minus e to the 3t. Okay, and that is 2t e to the 3t minus e to the 4t divided by e to the 3t. So you get what is it? 2t minus e to the t, right? You get 2t minus e to the t. It means that your a1 is integrate 2t minus e to the t dt. Okay, and that is t squared divided by 2, and this 2 cancel out, right? And minus e to the t. You don't need to plus the constant. Okay, you keep the constant, because you're gonna have another constant in front of a1 anyway, so just forget the constant. Okay, so you get a is t squared minus e to the t. Good. After that, we need to find a2, and we begin using the same rule, the Cramer rule. So to find a2, you need to replace this column to the second column, okay, and divide that by the same thing. So what you have would be e to the t, e to the t. This is fixed from here, and then you replace the yellow column to the second column, so you get t e to the t, e to the 2t. Okay, then I replace this yellow to the second column. Okay, I replace this to the second column, and then I divide this thing by the same guy, right? By okay, which is this guy. Okay, after right now I'm trying to go slowly, so I wrote this down. But for the next examples, I won't be writing this down because this is the same as that, and you already know it's e to the 3t. Okay, so down here you already know it's e to the 3t because you have already computed it, right? It's e to the 3t. So you need to only find the determinant of the denominator. Okay, so here what you have is e to the 3t minus t e to the 2t, and you would have 1 minus t e to the minus t. Okay, you have 1 minus t e to the minus t, and you need to find a2. So your a2 would be integrate 1 minus t e to the minus t dt. Okay, integrate 1 minus t e to the minus t dt, and that would be integrate 1 dt minus let's say plus integrate u e to the u du. Okay, when I let u be minus t. Okay, du is minus dt. Okay, oh no, it needs to be another minus here. Okay, let's go slowly. Okay, so that you won't get confused. Here that would be minus integrate t e to the minus t dt. Okay, this one is quite simple. It's t, right? This one is t. This one, not really sure. We'll get back to that. Okay, you just need to do integration by part. Okay, you just need to do integration by part. But how to do the integration by part? Okay, note here. If I let u be t, dv is, or how about if I use the shortcut, so you have t and e to the minus t here. Okay, I have t and e to the minus t here. You already know how to do the shortcut, right? I already taught you guys. So here is 1 and 0. We keep differentiating, right? Here we integrate. We get e to the minus t, and then we get e to the minus t. After that, you multiply down this way. Okay, and then you get plus and minus. So the solution would be minus t e to the minus t minus e to the minus t. Okay, so here you would get minus t e to the minus t minus e to the minus t. So this would be t plus t e to the minus t plus e to the minus t. Okay, so right now you obtain a1 and a2. So you can get the solution xp, which is a1 t square minus e to the t from here, a1. Okay, and x1 would be what is x1? X1 is here, right? X1 is here, which is e to the t. Okay, that would be e to the t, and then plus a2, which is t plus t e to the minus t plus e to the minus t, and then x2 would be e to the e to the 2t and 2e to the 2t. So I would get e to the 2t, 2e to the 2t. And this is actually xp. Okay. And your solution x would be just xc plus xp. Okay. If you really want to write that down, you write that down. I'll just write that down here. So I would get x equals xc. Okay, I'll just copy it here. It's xc. You might not be able to do this, but I can. And that is xc. And then you need to plus xp. And xp is actually this guy. Okay, I'll just copy and paste. But you know what I'm doing, right? I just, just copy and paste stuff. And that is the solution. Let me sum it up here. First, you want to solve this equation. You write that down in terms of matrix. Then you let, b be 0. You solve for the homogeneous systems, right? And then you get the eigenvalues m, right? And they are distinct. So you can just get, m1 and m2. Then you get x1 and x2. Okay, right? You get x1 and x2. After that, you look at xp, which is a1 x1 plus a2 x2. And then you look at a1 prime x1 plus a2 prime x2 equals b. This is the most important equation that I told you, right? And then you just write this down in terms of, matrix. And then you get this system of, equations in terms of a1 prime and a2 prime. And then you use Cramer's rule to solve for a1 prime. Once you get a1 prime, you can integrate to get a1. Okay, and then you use Cramer's rule again to get a2 prime. And once you get a2 prime again, you can integrate to get a2. Okay, this is a2 prime, right? Let me split that here so that you won't get confused. Okay, and you can integrate to get a2. This you need to do integration by parts, and then you get xp, which is a1 x1 plus a2 x2. Okay, and your solution is just xc plus xp, and you just write everything down, and that's it. Okay, next example. Okay, we are asked to solve this non-homogeneous systems. So first, again, I'll write that down in terms of matrix. Okay, so it would be, it's already in terms of matrix, right? So here is A and here is B. Okay, let me use some other color. So here is A and here is B. Okay, so first we want to find the eigenvalues m, right? We look at the x prime equals ax, which is the homogeneous case, right? When b is 0, we want to solve for xc, right? So first we look at the characteristic equation. So 2 minus 2 minus 1 minus m equals 0. So we get 3 minus m minus 1 minus m plus 4 equals 0. So we get minus 3, and here that will be plus m minus 3m, that will be minus 2m plus m squared plus 4 equals 0, and that will be m squared minus 2m plus 1 equals 0. And then we get m 1 minus equals 0. So m is 1 and 1. And that is the case where we have repeated roots. Okay, we need to see, if we get the first or the second case. Remember that, right? The first case is when 1m gets 1k, 1m gets multiple k's, and the second case is when 1m only gets 1k, and we need to compute k's recursively. Remember that, right? Okay, so we're gonna see. So first, we would look at the equation, which is, what is it? The a minus m1i k equals 0. Okay, so what we have would be when m is 1, right? So we get 2 minus 2, and then minus 2, k1 k2 equals 0. So we have k1 plus 2k1 plus 2k2 equals 0, which means that k1 plus k2 is 0. Okay, the other one, we have minus 2k1 minus 2k2 equals 0 as well, right? But that is the same equation as this, so we don't care. Okay, and right now we can write k2 in terms of k1. k2 is actually minus k1, and that is the first case. Why? Because we can write k2 in terms of k1. Okay, we can write k2 in terms of k1. So our k would be, what is it? Our big K would be K1 and minus K1. You can pick K1 as 1, right? And it's going to be 1 and minus 1, right? But in this case, I'll pick it as 2. You can pick 1, of course, and it works completely fine. But I'll pick 2 because, I'll try to do exactly the same as in the book. Okay, but you can pick 1, you can pick 5, you can pick 10, any numbers you like, except 0. Okay, so here I'll just pick 2, so I get 2 and minus 2. Okay, so 1m, sorry, this is not case 1, this is case 2. 1m gives you only 1k, right? 1m gives 1k. So you need to define k2 using the recursive relationship, right? So you need to look at this equation, which is a minus m2r. It's the same m, right? I just write m because m is always 1, so I can just write m, and then k2, okay, equals k1. Remember that we need to use this k1 and put it here in order to find k2. If you don't remember this, go back to the section 2.2, okay, when we were looking at the repeated roots when 1m only gives you 1k. Guys, this should be, the case that could be in the exam. Why? Because it's interesting. Okay, if there are going to be just 1 or 2 questions in the exam, it should be this kind of, questions. Okay, so try to focus on these types of questions. Okay, so next we would have a minus mi. You would get the same matrix, right? 2 minus 2 minus 2, and then you get k1 k2. Here you would get 2 and minus 2. Guys, this is the reason why I pick 2 here. Why don't I pick 1? Because you have 2, and if you pick 2 here, it's going to be really easy to compute. Okay, if you pick 1 here, it need to be 1/2 afterwards, and it's a lot harder to work with the numbers. Okay, but as I told you, if you pick 1, it works completely fine as well. Okay, I mean, when I say 1, I mean you get matrix 1 and minus 1. Okay, but here it will be 1 and minus 1, and it's going to be a lot harder to work here. Okay, anyway, here we would have that 2k1 plus 2k2 equals 2. Okay, and that will be k1 plus k2 equals 1. See, you get k1 plus k2 equals 1. But if you pick k1 as 1, you will get k1 plus k2 is 1 half. Right? So I want all to be integers. That's why I picked k1 and k1 as 2 at the beginning. Okay. The other equation would be minus 2k1 minus 2k2 is minus 2. But it's actually the same equation as that. So I don't care. Okay. Okay. So I have that k2 is actually 1 minus k1. So I have here k2 is k1 and 1 minus k1. So here I'll pick k1 as 1. Okay, so I get 1 and 0. Good. So I get x2, which is what is it? What is x2? X2 is going to be, guys, you need to memorize the formula. Okay, so x2 is k1 t e to the mt plus k2 e to the mt. If you remember, you have m and then reducing the orders. Okay, so you have here, which is k1 would be 2 minus 2 t e to the t plus 0 hold on 1 0, right? Once, how about if I pick guys, 1 0 works fine as well. Okay, but I just want to follow the book, so I pick k1 as 0, so I get 0 1. Would that be fine? Okay, when k1 is 0, I get 0 and 1. Okay, but again, as I told you, 1 0 is okay as well. Okay, but I just want it to be exactly as in the book. Okay, so right now we get x2. So xc would be c1 x1. Where is x1 again? Oh, I didn't write down x1, right? No, sorry. So let me put it here. Okay, I'll push this down here, and then I'll just write down x1 here, and that is 2 minus 2 e to the t, right? So x1 would be 2 e to the t minus 2 e to the t. Okay, that is c1 x1. Good. And then plus c2. x2 would be, what is it? What is x2? x2 would be 2 minus 2 t e to the t plus 0 1 e to the t. Okay, I just get rid of my video. Okay, from here, this is x2. I'll put it here. Okay, is that good? And then I try to make it looks simplest, so it would be c1 2e to the t minus 2e to the t plus c2, and that would be 2t e to the t minus how about I get 1 minus 2t e to the t. Is that good? 1 from here. Okay, minus 2t, and then we have the common factor e to the t. Good. After that, I'll just say that here this would be the form of x1, right? And it will be the form of x2. Okay. So right now we say that xp is actually a1 x1 plus a2 x2. Okay, and we can solve for a1 and a2 using this equation: a1 prime x1 plus a2 prime x2 equals b. Again, this equation, I told you, the most important equation for non-homogeneous systems. Okay, so you get a1 prime x1 would be 2e to the t minus 2e to the t, and then plus a2 prime 2t e to the t 1 minus 2t e to the t equals, and your b would be 2e to the minus t and e to the minus t, 2t e to the minus t and e to the minus t. Okay, and that is the systems. Okay, and then we rearrange it a bit, right? We write that down in terms of some metrics. So we have 2e to the t minus 2e to the t. This is from here. Okay, and then we get 2t e to the t 1 minus 2t e to the t, and this is here. Okay, and that is equals to e to the minus t e to the minus t, and that is the system to solve for a1 prime and a2 prime. Sorry guys, I forgot a1 prime and a2 prime here, right? There should be the vector a1 prime and a2 prime here. Okay, and these they are equivalent, right? They are equivalent, they are the same equation. Good. Next, I'll look at a1 prime. Okay, next I'll just look at a1 prime. What would a1 prime be? You need to replace this to the first column, right? So your determinant would be, what is it? 2e to the minus t e to the minus t 2t e to the t 1 minus 2t e to the t divided by 2e to the t minus 2e to the t 2t e to the t 1 minus 2t e to the t. Okay, this is actually here, and this guy is actually this one, but replace the first column by this. Okay, and guys, it looks horrible. It looks very horrible. Okay, I think you guys can do the determinant, right? So I'll just give you the value. Here is 2e to the 2t and 2 minus 6t. Okay, you can try to to go from here and here yourself. Okay, you just multiply down and multiply up. Multiply down you get plus, multiply up you get minus. Okay, and you will get just this. Okay, in that case you would have that a1 is actually integrate 2 minus 6t divided by 2e to the 2t dt. Okay, and that is integrate 2 minus 6t 2 minus 6t. Can I I'll just get rid of this, then I get 1 and 3, so I get 1 minus 3t e to the minus 2t dt. Okay, and you use integration by parts. Okay, and the answer is, okay, I'm not gonna show you. Okay, you can do that yourself. Use the integration by part. So the answer would be 3/2 t plus 1/4 e to the minus 2t, and that is your a1. And similarly, if you want to solve for a2, your a2 would be a2 prime would be you substitute this to the second column, so you would have 2e to the t minus 2e to the t, and then 2e to the minus t, e to the minus t, divided by the same guys, which is 2e to the 2t, this same guys. Okay, and this, you just do it yourself. Okay, I'm not gonna show that. Up here you would get 6. It's quite easy, you multiply there, e to the t and e to the minus t cancel out, right? So you get 2, and then you get plus 4, so you get 6. That is quite simple. And you get 2e to the 2t, so here you get 3. Okay, so that is 3e to the minus 2t. So a2 would be integrate 3e to the minus 2t dt, and your a2 would be minus 3 over 2e to the minus 2t. You can integrate this guy, right? You let u be minus 2t, right? And du is minus 2 dt, right? So dt would be 1 minus 1 half, and that is your integral. Okay, so right now you know that your xp is a1, which is 3 half t plus 1/4 e to the minus 2t, and then x1, your x1 would be this guy, right? This is x1, right? xc is c1 x1 plus c2 x2, which reduces to this form. Okay, so your x1 would be, what is it? 2e to the t and minus 2e to the t, and then plus a2, which is minus 3 half e to the minus 2t, and then a2 x2 would be 2t e to the t and 1 minus 2t e to the t, right? And that will be xp. Okay, don't forget, this is x1, this is x2, okay, and this is a1, and this is a2. Okay, so your x would be just xc plus xp. I'm not gonna write that down, okay, because you can get xc from here, right, which is this guy, and then you can get xp. Let's use the blue color from here, which is actually this guy. So it's gonna be quite long, but you can just keep writing them down. Okay, the last question, I'll let you do it as an exercise. Okay, and guys, that's it for the 4th chapter, which is the systems of differential equations. Just to sum it up, we first look at the introduction, right? What the systems of differential equations are, right? And then we look at the homogeneous case. In that case, we split it into 3 sections, which is the distinct roots, repeated roots, and the complex roots. For the repeated roots, we split that into 2 cases. The first case is when 1m gives multiple k's, and that is easy, right? You just need to write 1k and then you split that into 2k's or 3k's, right? The second case is in 1m only give 1k. In that case, you need to get k2 using k1 and k3 using k2 and blah blah blah. And the x will take the specific forms that I gave you in the lecture note, right? You need the formula for x. And in this video, we look at the case when the systems are non-homogeneous. In other words, when b is not 0. Okay, in that case, we need to solve for yc first, which is the same as the previous case, right? When it's homogeneous. And then when we solve for xc, right, we get, xc in terms of, c1 x1 plus c2 x2 plus c3 x3 blah blah blah. And we use that x1 x2 x3 x4 to define xp, because xp is a1 x1 plus a2 x2 plus blah blah blah, right? And then we can solve for a1 and a2 using the equation a1 prime x1 plus a2 prime x2 equals b, right? And that is the most important equation for non-homogeneous systems. Okay, and you can solve for a1 prime a2 prime using Cramer's rules. After that, you integrate a1 prime, you integrate a2 prime, you get a1 and a2. So once you get a1 and a2, you get xp, which is a1 x1 plus a2 x2. After that, you get the solution x, which is xc plus xp. Okay, and guys, and that's it for the fourth chapter. We have one more chapter to go. Okay, we have one more chapter to go. So guys, try to watch the videos, try to keep practicing. This chapter is actually very easy. It's just very long, it's just very lengthy. Okay, so you just need to do exercises, try to practice, and you will get good scores. Okay, if you have any questions, don't hesitate to contact me. Okay, you can ask me questions. I am very happy to help. Okay, I'm here to help. Thank you. See you in the next video, guys. Bye bye.